Alrighty. So now we're going to look at a lamppost problem. And we're going to talk about a man walking away from a street light. So he's walking away, the light's shining on the man, and he has a shadow. And we know that the street light is 21 feet above the ground, and we want the rate at which the length of his shadow is changing. And then in part B, the tip of his shadow, what rate is that moving? Okay, so we're looking at two different things here. Okay, so let's start with getting a picture of what's going on. Okay, so we have a street lamp here, and it's shining light down, and we have a man walking away from that. Okay, so let's say that the man is right here, and then the light kind of does something like that. Okay, so we've got two different things here. We've got two triangles going on. So we know that this is constant, this 21 feet right here. But this variable right here, this is changing. I'm going to call that x because it's moving. And we know that dx dt is 3 feet per second. Okay, and then here's his little shadow over here. And we want to know, okay, well, what's the rate of that, the change in the length of his shadow? Okay, so we're trying to find ds dt. Okay, so, and then the other question asks us for this point, the very tip of the shadow, what's the rate at which that's moving? So one is the length of the shadow, like how long is it or how is it changing, versus how fast is the tip of the shadow moving forward. Okay, so what we have here really is similar triangles. Okay, so let's look at the big triangle. And I'm going to say I know this is 21, and I know this is x plus s. Okay, then I have the little triangle, the one made by the man, and he was 6 feet tall, and that is his shadow. Now, these are similar triangles, and just a quick little reminder for you that this angle right here, that angle's the same. That's the same angle here and the same angle here. Okay, so they both share that same angle, and they both have a right angle. And there's a theorem that said, it was called angle-angle similarity, that if two triangles have two angles congruent to each other, then the triangles are similar. Now, similar just means it's like a copy machine, like you expanded it or condensed it. So their sides are going to be in proportion. So I'm going to go side is to side. So 21 is to x plus s as side is to side. So now I have a way that these things are related to each other. Okay, so I'm just going to cross multiply. So 21 times s is equal to 6 times x plus s. So 6x plus 6s. I'm going to subtract 6x, or 6s, I should say. So 15s, 6x. Okay, so I kind of like that equation right there. It looking like it doesn't even matter what's going to happen with that 8 feet right there, because I'm trying to find ds dt. I know dx dt. So I think I've got enough here. So let's go ahead and differentiate. Okay, so that's going to give me 15 ds dt is equal to 6 dx dt. Okay, so then that tells me that ds dt is 6 times dx dt. We said it was at a rate of 3 feet per second. Okay, so we got to think about, is it positive or negative? Okay, so if he's walking this way, he's walking away from the light, then x is getting bigger. Okay, so that's going to be a positive. And then I'm going to divide by 15. So ds dt is going to be equal to 6/5 of a foot per second. So every second, his shadow is changing by 6/5 of a foot in length. Okay, so now let's look at what rate is the tip of the shadow moving. Okay, so we're looking at this length right here. So this one's a little, it's kind of tricky. So we still have the same thing going on here. So I still have my 6, and I have my S, and this time I'm just going to call this one L for the length of this whole thing right here. Okay, so now I'm going to do the same thing. I'm going to go 21 is to L, because that's what I want to find. I want to find the length of this whole thing is equal to 6 over S. So 21S is equal to 6L. So again, we can see this 10 foot isn't even coming up in this problem at all. Okay, so I think I've got everything I need. Let's go ahead and differentiate. And then we're going to have that 21 ds dt is equal to 6 dl dt, which is what we're trying to find. So what do we have? 21. We know that ds dt, we already figured that out right here. And I don't have to recalculate it for 10 feet because this didn't even matter about with the 8 feet. It had no effect on it. So I'm just going to use that from that problem. Okay, is equal to 6 times dl dt. So then I would divide both sides by 6. And I could see those 6's would cancel out. So 21/5, and I'm going to say dl dt is equal to 21/5 feet per second. So a little over 4 feet per second is the rate at which the tip of that shadow is moving. Alrighty.